So here we're going to show that the limit as x approaches 2 of x squared is equal to 4, which this is another one of those plug it in and you get it right off the bat. You know 2 squared equals 4, so that works out. We are going to use the formal definition of a limit to prove this to be true. Proving something is a lot easier than just saying it. So I'm going to give you a step-by-step how to work through these types of problems, okay? In general, okay, so just this is in general. For the formal proof part, what we want to start with some x minus c less than delta. Remember, this is the formal proof. And then I want to conclude that if that is the case, then the distance between f of x and L is less than epsilon. That's what I want to prove. Now, this delta here is dependent on epsilon, okay? So, how do we do it? How do we actually do it? That's the formal proof. How do we actually go about doing this? Well, we need scratch work. We got to write out the scratch work first so we can figure out, you start with what you want to conclude, and then we work backwards to get to where we start, right? So we start here and we finish here and we figure out what the delta needs to be in terms of epsilon. That's the scratch work. So I start with the absolute value f of x minus the limit is less than epsilon, okay? From there, I then perform some algebraic manipulation. And once I do this algebraic manipulation to give me some inequality in the form of x minus c. So for this particular one here, my c is 2. Okay, as x goes to c of f of x, and then equal to the limit, right? So my c there is 2. And so that equals something. I don't know what it is yet. That's what the scratch work gets me, that something. And that something is my delta there. And once I have that, then I work backwards from there, writing down all the steps in the formal proof. Okay, so that's the flow in general. All right, so I want to see everything. I want to see your scratch work, and then I want to see the formal proof written all pretty. Okay, so the scratch work, we do all that scratch work so we get that beautiful delta, which is in terms of epsilon, when epsilon is arbitrary. And then I start with that final scratch work and I work my way down till I get the desired result. So let's do it. So what do we want? Okay, I want to have the limit, or not the limit, the absolute value f of x minus L less than epsilon. That's what I want. That's my ultimate goal. What do I need for that to be true? I need to have x minus c less than delta. That's the definition, okay? Precise definition. So I need to know what the players are. Okay, you think about it for a second. It's the limit as x goes to c of f of x equals L, okay? So the c is my 2, the f of x is my x squared, and the L is my 4, okay? So I know the players now. All right, so I replace f of x with x squared. I replace L with 4. And what I'm going to do is I'm going to work with this to try to get a delta. And so first thing I see I can do is I can factor. And so I'm going to factor inside here. And so whenever I do that, and look, guys, what am I trying to get by itself? I need absolute value x minus 2, right? Well, if I see x squared minus 4, I'm thinking, oh, that's a difference of squares. I can factor that out, right? And now I have exactly my desired. Well, how do I get it by itself? Instead of multiplying here, I'm going to divide through by this x plus 2. But we got ourselves a little bit of a situation here, because I have delta equal to epsilon divided by x plus 2. But what does that even mean? Delta must be a constant, right? It's a fixed number, okay? So we've got a situation here because I've got an x in here, which all of a sudden makes delta not a fixed number anymore. So there's a way to get around this. And the way to get around this is relying on the fact that epsilon is supposed to be a small number. Remember, epsilon is greater than 0. We're thinking of some really small number like 0.0001, right? So something tiny, okay? If epsilon is this small positive number, that implies that delta is going to be small too, okay? So I'm going to do a restriction on delta, and that's going to help me get a delta that is not determined on x, a function of x. And so what do? Something small here. I'm going to let delta be less than 1. Okay, so a common thing to do here, let delta be less than 1. So we're restricting delta. So what do we have? What do we need? We need for x minus 2 to be less than delta. Well, guess what, guys? If delta is less than 1, then that means x minus 2 in absolute value is less than 1 by transitivity. If you think about it for about 2 seconds, you can see that this would be the case. Therefore, that's less than 1. Okay? Now, using algebra here, I take care of my absolute values. And so what do I have? I got -1 to 1 here. I want to get x by itself, so I'm going to add 2. And if I add 2 to everything, I get x is between 1 and 3. Okay? X is stuck between 1 and 3, assuming that delta is restricted to be less than 1. Now this is going to help me here because now I have a bound on x. So how does it relate to this here? Well, let's see. What do I want? I want to get this x plus 2 thing going on here. I want it to look like this expression here. So how do I go from here to here? Well, guess what I got to do? I got to add 2 to 1 and 3. And if I do that, I get 3 and 5 here. Okay? Now, what do I know? I know that x is stuck between 1 and 3. So if I add 2 to this, it's going to be positive. So if I take the absolute value of this inside, it's still the same thing. There's no effect on that. Okay? Furthermore, now I'm going to do a trick that's very, very powerful. This is reciprocal of inequalities. You think about it like this. If I have 3 and the number 4, clearly 3 is less than 4, and that's less than 5, right? We agree on that? Well, guess what? If I do the reciprocal of this, is it true that this is the case here? No, 1/3 is bigger than 1/4, right? Actually, it reverses, okay? So what do I mean by it reverses? I mean this right here, okay? The bigger the number is, the reciprocal of that number is smaller, okay? So if I do the reciprocal here, right, what's going to happen? This 5 comes over here, and that 3 goes over there. Okay, so let's work through all that. That's a very powerful technique there. And so the rule is this: if A is less than B, and that's all greater than 0, then I can use this inequality here. This is a very useful inequality. Okay, so you will probably use this a lot here. So make sure you know that inequality there. Very powerful. Okay. So that's how we go from here to here. Now, What do I want? This almost looks like what I wanted here, right? I'm algebraically manipulating it. What am I missing? It looks like the only thing that I'm missing is an epsilon. So what am I going to do? I'm going to multiply everything through by epsilon. And I can do this and the inequalities stay the same because epsilon is arbitrarily small and positive. Okay, since it's a positive number, then we don't have to worry about the inequalities changing direction. So what do I have now? I now have exactly what I had here, which is what I wanted. And so what does that tell me? That tells me that delta is greater than epsilon over 5. Okay? Delta is greater than epsilon over 5. All right, that's what I wanted. Now,